Okay, so hello everyone, welcome to my talk. I just want to share you the Slido link, so if you have any question, feel free to take the QR code and answer your questions. Here we are. So, okay, topic of my talk for today is jack of all trades or making better technology decisions. About me, my name is Kuemmel. I'm software developer and project manager for 15 years now. I'm since 2019 part of the MicroStream team and currently the project manager of the MicroStream cluster development. And I'm also involved in different other projects as project manager, for example, within the Allianz Insurance company for economic trade sanction screening, and also on the Fraport German airport for the baggage handling concealing system. And then on top of that, I'm also traveling around and standing at the booth and doing talks and so on. And you might say, okay, so now you are also a jack of all trades because of that. And yeah, you are right in a way. And that is also the reason for this talk. I'm talking with a lot of guys. I'm seeing a lot of projects, and also I see that a lot of people struggling with their projects, especially when they increase, when they're growing, and so on. And I know that I knew that these are harsh words. So 80% of all projects fail, but this is in fact, when you Google for it, you will see a value between 75 and 90% of all projects failing. And I would say not failing in total, but failing in waste of resources, and projects are out of budget or not in time. And there are many reasons for that. And as you all know, there are different imaginations of the product at the end, different budgets and unpredictable changes, and no available specifications, wrong estimations and promises, and so on and so on. And most of the time, these things are, I would say, management issues or problems that we have. But there are technology problems that we also have. And these problems I want to talk about within my session. Okay, these three topics are the important ones, in my opinion. The first one is striving for perfectionism. And I think that's a typical thing, especially within the development community. We all try to get the best framework, the best features in every framework and tools and stuff like that. And when we start a project and we see after 5 months a new version is upcoming with new features, we want to have that, and that is really great. So that's one point at this time. The next one is the ignorance and the overestimation of actual needs. That's also very interesting, especially with the overestimations. It relates a little bit to the perfectionism. The point is that, as I said, we always want to have the best product for the project. And ignorance of the needs. So we will talk about that later a little bit deeper. And last but not least, in my opinion, the fairy tale of scalability. That's also an interesting point. As I said, I'm project manager of the cluster of MicroStream and so on. So at the one hand, I'm a big fan of scalability. On the other hand, I don't like it. So, but let's talk about that later. First point, perfectionism. And there is one guy, he lives in the 17th century. His name is Voltaire. He invented a really famous sentence: perfection is the enemy of good. And this is quite funny because I've seen a movie 5 weeks ago, which is called Blackberry. I don't know if someone of you have already seen it. And there are two situations with the same sentence. And the first one was that the boss told his developers and said, okay, they forced them to create a prototype, and the developer says, okay, if I could do it perfectly, I would do. And not on the other hand. And boss said, okay, you have to do it, and it don't has to be perfect, but it has to be good enough. And the second situation is they started the Blackberry, even that they know that only 500 or 1,000 devices could be handled within the network, within the server. And yeah, they launched it anyway. And yeah, it works. We see that Blackberry was very successful at the beginning. And there is another guy which used the same sentence in a different way. And he said perfection is the enemy of progress. And that's, in fact, the truth. There is another point, and we call it Pareto principle, and it says that the 20% of the effort we have on a project results into 80% important things within the application itself. On top of that, there are 80% we do after that, and this will lead into 20% result, not important features. That is quite interesting. That means that you have to focus on the very important 20% of a project, and then you should be good enough in this point. Whenever I talk to people on the booth, and we're talking a lot of databases and scaling and stuff like that, and when they are evaluating a storage technology, they always look for limitless scalability, so data scaling. So we talk about data replication. And they're also looking for high availability also. So that means that in that case, it is replication, I would say. It always has to be strong, consistent, right? So that's what we all know, or what we all want, strong, consistent. It should be easy to use, fast as hell, of course, as cheap as possible, and on-premise, because nobody wants to give the data back to any other infrastructure than my own. And as always, they want these points all at once. Well, the truth is, you can't get this all at once. There is one which is called the cup theorem. I think every one of you knows that. It's impossible to get all the first three features at once. You can get slightly, but no at once, or no all at once. It has to be strong, consistent, but on the other hand, fast as hell. That's also a problem. If you force strong consistency, you have to wait for all the data is replicated, and that ends in a lack of performance. And at the same time, when we talk about limitless scalability or high availability, we always want to use infrastructure, and yeah, maybe infrastructure that you not have on-premise. And yeah, then it's difficult to have that on-premise. So you see there are some more things that could come together, or that couldn't come together. And yeah, that's the thing. Yeah, what if you want to have a solution that fits best to your needs? And I want to share you an architecture. And does any one of you knows what architecture this is? Just have a short look and tell me if you know that architecture. Have you ever seen that before? Someone? This is in fact the architecture of WhatsApp. It might change a little bit during the last few months, but this should be the architecture. And the interesting point is, just have a look what kind of technology you are familiar with. Is there something you know or you have seen before? So in my opinion, there are two. We see SQLite, of course, everyone knows it. And there is another one in the middle, MySQL and PostgreSQL, and that's it. I've never heard of all the other technologies within that architecture. And that's the point. So when you want to create a proper architecture for your needs, and if you want to have the best result of scalability and so on, you have to build it by yourself. And this is quite expensive, and it's quite effortful at the end. In my opinion, the important thing is trying to see both sides. So that means nowadays, we sometimes lost the ability to see both sides. standing in the middle and taking the best from both sides. We see that on the political parties, we have always a good and bad side. We see that on e-cars and gas cars, people who are driving e-cars care about environment, the other not. We see that on vegans and meat eaters and stuff like that. And of course, we have these two guys here. They never would come together. But it's also a big issue within the IT. So we always fight against, when we talk about Linux versus Windows, when we talk about microservice versus monolithic apps, horizontal versus vertical scaling, and of course, cloud versus on-premise. And sometimes it feels like the experts all using cloud and the on-premise guys are the dinosaurs from the last century. But it's very important to stay in the middle because microservice and monolithic apps comes together. It's a really great solution. We should take best of both sides. But the important thing, if you need to make decisions, you need to know what are your needs. And that's exactly the point. And I think the easiest one is the basic technologies. What kind of UI technology should we use for our project? And when we see those technologies, JavaFX, Vaadin, for example, JavaScript and React, we see, okay, they are made for specific use cases. JavaFX for desktop applications, Vaadin maybe for server or client-side web applications, JavaScript for client-side, and React, and so on and so on. That's an easy decision, right? So, but what about when we ask for how many concurrent users we will have? Or how many requests we will have per second? That's a quite challenging question. And let's step a little bit deeper into this. So let's talk about the users. The first thing is the fact that, or is the question, does an increasing amount of users influences my infrastructure? In case of desktop applications, it will not. But in case of web application, maybe, especially when it is server-side UI, then maybe this is the case. Next step is, we have 500 users at beginning, 5,000 after 1 year, and 500,000 maybe after 5 years. Who knows? So which is the sweet spot to start at the beginning? How to calculate that? Is it okay to say we need a technology that is able to handle 500,000 users at a time at the beginning of a project, after 5 years maybe? And to be honest, you will re-implement some stuff of your application within the first 5 years anyway. So you should try to find a sweet spot, something between 500 and 5,000. And it's the same on the request side. We always say, okay, 500 requests per second is a lot. Who knows? It could also be that 2,000 are a lot. Who knows? What are the differences? The point is, when you try it, when you, for example, you use a Micronaut server and you deploy it, and when you have an empty request, for example, you will be able to reach more than 65,000 requests per second. And I think that's a lot. But it depends on the business logic within the REST endpoint. And that's a developer topic. So you have to take care about to keep your endpoints as lightweight as possible and as efficient as possible. And there is another point. You have to be able to test it also. So I would suggest following. So keep business logic as small and as efficient as possible. Of course, that the higher the frequency of an endpoint is, the more lightweight the code should be. You should not worry about the next 5 years. Take care about the first 6 or 12 months. So that makes definitely more sense. Keep your project as modular as possible. And that doesn't mean using microservices. That means using modules, we don't talk about microservices. Find parts or modules that make sense to keep it as a module. So, and it doesn't matter how big it is. It must be, it has to make sense, I would say. And at the end, and after a certain amount of time, find new different solutions for different needs after a year or 2 years or whatever. Because you're learning with your application. You have to learn how does the application react if users grows and so on. Makes it easier to make decisions. And at the end, try to scale vertically, especially with stateful services. Stay as long as you can on the vertical scaling part. The next needs we often ask for, what about storage? How many storage do we have? And this is also quite funny because people coming to the booth and asking for, okay, hey, MicroStream, or EclipseStore is a great technology. So I have an Oracle database. It consists of 20 terabytes of data. And this is a true story. And they ask, okay, can we move to EclipseStore? Does it make sense? And the truth is, we talked to them and we say, okay, you know, EclipseStore is an in-memory database. Could you imagine that you have 20 terabytes of RAM of your, in your server? Okay, so we talked with them. We say, okay, let's say 20 terabytes of data. How many binary data are part of your database? And they said, around 50%. And that's okay, because binary data is the heavyweight data of a database. And we said, okay, take them out of your database. You don't need it there because of 2 reasons. The first reason is you need a system that can scale automatically. So let's choose AWS S3. It's easy, it scales automatically. You don't have to take care about this binary data, it's okay. And the second reason is you don't want to have the traffic, or you have to want the traffic on your application server. When you access binary parts, images, photos, documents, whatever, the stream or the traffic goes all the way through your application server, and you don't want to have that. That's the second reason. Keep it on any binary storage, doesn't matter what. It's just an example. Next part, archive data. That's very important. I asked them, is it necessary to always filter through the last 20 years of your data? And they said, maybe yes, maybe not, but it's okay for us to see the last 3 years. That gives you the possibility to make a decision to say, okay, let's transfer every night data older than 3 years to an archive. And archive could be any other data storage with, I would say, medium or low performance, because you access that archive once or 3 times a month. Doesn't matter. But don't keep it on your main database. Next part, main storage. And even main storage could be divided into separated things. You could have the base data. I'm talking about customers, addresses, and so on. Data which is not highly changed, or which is not changed that much. Only reads and stuff like that. Choose a NoSQL solution or whatever. Any fast solution. And there is another thing, I would say, motion data, for example. Data, it's always changing and progressing and so on, like orders, or it depends on your business. Use an in-memory solution, like MicroStream, EclipseStore, and so on. And then we have, at the end, 10% of all individual data, whatever. You could choose whatever technology fits. I think the point here is find different types of your data to deal with that data differently. It makes it much more easier to find the right technology for the right type of data. And I think that's the time is over where you say, okay, we have 20 terabytes, there is one Oracle database, put everything in it. That doesn't make sense, really. So to summarize that a little bit, as I said, avoid scaling main data as much as possible. Move data to archive. And this is the part where I say this is the fairy tale of scalability. Keep your data small all the time, and then you don't have to scale it because it renews all the time, and that prevents you from scaling that much, keeping things cheap, I would say. Try to scale data always vertically, use systems that scale easily. That is the point where I said use AWS S3 or any binary parts for binary data. And at the end, you should be careful, especially when we talk about scaling stateful data. Is insane expensive. On the first part, you have insane costs of infrastructure, insane need of know-how, high demand of good stuff, and this is also expensive. And at the end, dealing with strong consistency, eventual consistency, that gives you restriction you want to have. You don't want to have. And of course, at the end, enormous security requirements. Next part is the part modules versus microservices. I have to step back a little bit. Yeah, last part is features of the application that might be resource relevant. That's also an interesting point. When we talk about microservices and so on, you should find special parts of the application. So I give you an example. We have a straightforward application. We have a front end somewhere. We have an app server in between. And we decided to have two services. The one service provides base data, another one provides the motion data with different technologies, whatever. And then we talked about the AWS S3. So we could do it like this. So we have the S3 bucket here, and to find the data we use an Elastic server, or could any other possibility or any other technology, whatever. It's important to find the right documents, and then the front end could access directly to the bucket and gets the document. On the other side, we see another server or module for the archive data. We don't want to have the archive data within the app server because when people loading archive data, this could be quite heavyweight. So I don't want to have that on the app server because it should be fast and also maybe slim. And we used a special archive data server to provide archive data within JSON stuff, also maybe on AWS S3. And last but not least, the green part here, whenever we talk about heavyweight task, you should do it within microservice maybe. One service for creating PDF reports, one service for creating CSV exports, and so on and so on. There are many different possibilities handling things within microservices or modules. And I marked that points here with black borders here. You see that? Some of them are black, some of them not. And the point is, all the black stuff here are stateless elements. So that means could be deployed to Lambda, could be deployed to some other infrastructure. This or could be clustered. So it could be scaled horizontally with no problems, because all these things are stateless. And that is great. So that saves cost and effort and so on. It depends on your needs within your application. Okay, last but not least, talk about the scalability a little bit more in detail. The question is which sides you belong to. This one, this guy, and you said, hey, this is great to have the opportunity to scale, of course. Scaling stateless things is an easy task and that's it. Or you already found a technology that fits best for you. So you're great, that's okay, that works. And if you have enough money and resources to handle that. Or you belong to this side. You have to scale stateful things, and you don't have enough money and resources to do that. And then I would say be careful on your next steps. Let's compare this part a little bit, because I have to explain that a little bit in detail. So we see that. So on the top we have 2 Kubernetes pods. Each of them has 0.5 cores and 1 GB of RAM, and we have an EC2 instance on the bottom. So, which one is faster and more powerful or cheaper? What do you think? I don't know. It depends. Next example. Which one is faster, more powerful, or cheaper? We don't know. The point is, we're asking for availability. The question is one of them here more available as the other? We could have multiple pods on one EC2 instance, so that means we have application within threads, I would say, or we have applications within pods. I would say, yeah, there is no more availability because, as an example, AWS provides you 99 dot something availability. It's the same on resilience. You get 99% of availability of all resources of AWS. Why to cluster them? And I'm pretty sure there are a lot of solutions on the market which are deployed on an EC2, and they said to you, hey, it's a cluster, it's scalability, it's super, do that. But in the end, in a bigger screen, you could only vertical scale that because it's part of one EC2 instance. And you will never know. But when we talk about scaling up and down, and applications are growing more and more, as an example here, then scaling up and down could be an issue. And then it makes sense to talk about this, to talk about scaling. But I'm pretty sure that 70% of all projects on the market doesn't need scaling that much, especially stateful services. Let's talk a little bit of the efforts here, just to give you an idea what you have to consider when we talk about scaling within Kubernetes and stuff like that. You have to calculate your hardware costs. So we need, as an example on AWS, we have to talk about an EKS that consumes Fargate or consumes EC2 instances. We have to talk about, Fargate is more expensive. We have to talk about load balancers and network traffic and many, many different other technologies that comes into play with a Kubernetes cluster or an EKS. You need to have employees, that developers, DevOps, and so on and so on, very, very experts. And of course the knowledge. The core language is important: Kubernetes, clustering, network, load balancing, CI/CD, security monitoring, and so on. And there's a funny thing. I saw some projects in the past where the maintaining stuff around the project was twice or third times more expensive than the project development cost itself. You have to consider this. This could be especially monitoring and security, CI/CD, and so on. That's really, really expensive. Compared to the bottom side, to a normal EC2 instance, could be handled easily with some developers and using CI/CD, maybe also monitoring, but it's not that necessary like with Kubernetes. I always would recommend to keep it as simple as possible. That's easy, and better asking for what instead of why. So when we ask for why to use Kubernetes, you would say, oh, it's great, so many features, we could do this and scaling and stuff like that. But these are not your needs. You have to ask for what. What is the benefit for my solution, for my project, and does it help that lot? Makes more sense to ask for what. You know that small guy down there? It's I don't know if you heard it. It's a US startup. 2.0 is not on the market anymore, but they raised I don't know, 300 millions, and it's it doesn't make sense, that product. So not really. Just a small example to give you an idea what you can do when you keep it simple. This is the project I told you at the beginning from the Allianz Insurance company. It's, as I said, it monitors trade sanctions of different companies. We started 2018 with around 100 concurrent users. That was the thing in 10 countries with 40 gigabytes of data around. And yeah, during the time it grows more and more. Currently we are at around 2,000 concurrent users, 15 countries, 300 gigabytes of data. And as far as I know, this is just the base data, so it's the main data, I would say. It's not the archived one. The archived one is not included here. And at the beginning, we used an EC2. Now we moved to Kubernetes. And the funny thing is, we did not use that much Kubernetes features itself. It's just because the Allianz changed from EC2 and some other stuff to Kubernetes, and now we have to deal with it. I want to share with you some technologies we did it. So we used Vaadin as a great UI technology. I think the guys from Vaadin are also here on the conference. There are two different technologies available. So as far as I know, one is Hiller, it's the client side thing, and the other one is Flow, which is the Java part, and you will get HTML, JavaScript at the end. Really great. The second one is MicroStream or EclipseStore itself, a storage technology which fits for a lot of different solutions, or as an alternative to relational databases and so on. Both are compared within RapidClipse. These guys are also part of the conference. Inside that project, during the time, we split it up the product a little bit. So we split up to a data provider with EclipseStore and MicroStream, and we deliver the data to a Vaadin front end, which becomes stateless at the end. So we are able to cluster the front end, and we deliver the data to the front end. We used Lucene on top of that to add some more or proper search functionality, and and after that, this is the point, we used 95% only Java, 5% CSS, 1% YAML, and that's it. No SQL, no Hibernate, no HTML, no JavaScript. And that's really great. Keep it simple. This is working really great. Okay, so time for your question. I'm very too fast, but if you have any question, feel free to ask them. So let me just switch to, oh, come on. Okay, oh, I can't see this. Quite a mess. Give me just a second. What is your opinion to mix microservices and monolithic apps, and do you think it could make an end of the discussion? Okay, the point is there any definition of microservice on the market? Have you ever read a definition? How big should a microservice be, or what is a microservice, when to use it? Have you ever seen a definition of that? No, there is no. It's an idea. It's born somewhere from a guy, I don't remember the name, but there is no definition. And in my opinion, it makes sense if you have big teams, really big teams, and you have to split up the work and split it to the whole team to ensure the development itself. Then it makes sense. But on the other hand, you have to take care about communication between the microservices. Infrastructure is quite heavy to manage, and so on. I would say, based on the fact that there is no definition, make your own microservices. Think about what could be modular, which module makes sense to make it work within your architecture, and try to find good solutions or good moduled parts in your application. And if it's okay for you, create a monolithic app. If it works for you and it keeps things easy and it works, why not? But you have to consider maybe in some months or years, it is easier to switch some modules instead of switching the whole monolith. I think that's the point. Okay. Yeah, that's interesting. There is no definition of module. So create things that make sense. And you have to think about, does it make sense to have that as a module for you? Is there maybe the chance that you have to change it when the application grows more and more? Then it makes sense to create a module to make it easier to change the technology. I think that's the point. So create things that make sense, I would say. Okay, if there are some more questions. So that's all from my side. If you want to take or want to talk a little bit with me, you can meet me at the booth. And yeah, that's all from my side. Thank you for your attention. Enjoy the conference. Thank you.